So the next topic that we're gonna discuss is about the telescope. Now the very first one that we are discussing is about the giant Meterwave Radio Telescope. That is giant, first one, giant Meterwave Radio Telescope. Now this one is located in Pune, or you can say near Pune, and it is basically the deep space objects such as galaxy, neutron star, pulsar star, etc. It is well capable of determining these things. So the deep space objects like galaxies, neutron stars, etc. So this is what it basically majorly used for. So it's an array of 30 fully steerable parabolic radio telescopes of the 45-meter diameter. So there are multiple telescopes are used. So so if this is a whole one area, and this area we divide it into multiple basically rows and columns, and in each and every one of them we place a one telescope which basically provides certain amount of the data, and in the end an entire image is created by combining all the records of all these telescopes. So this is what we call as a complete array. This is an array, right? So this is an array of similarly the 30 fully steerable parabolic radio telescope of the 45-meter diameter. So this is what it is, the giant Meterwave telescope in Pune. The next one in the list is the Gemini Telescope. Now this telescope is in Hawaii. Now this is a radio telescope of the United States, and it is used to measure the distance to the galaxy. So I will write it here, the distance to the galaxy. So this is what it majorly used for. So the distance of the radio galaxies is measured via what we call as redshift. And the farther away the galaxies are, the faster they move away from us, and therefore appear to be there redder due to the Doppler shift. So generally this is a concept, if you read about the Doppler shift, so let you explain this concept, because I was gonna explain this thing later in the geography, but here it's fine. Generally what happened, Doppler effect is basically if this is you, right, this is a train track. So generally what happened when the train comes, so if the train comes here, you will hear its voice from very far away, right? So the moment it gets closer to you, the range of the frequency and wavelength of the sound itself increases, right? And when it passes away from you, similarly the sound and the range, frequency and wavelength, it keeps on decreasing. So this is this effect of increasing and decreasing when an object comes closer to you and moves away from you. This whole procedure is called the Doppler effect. Now generally what happened, the same principle is used to determining the distance between the galaxy, that how far are they from us and how closer they are from Earth. So if there is one object, if it's going actually, if this is Earth, if this is an object, right? Now if this object is going farther, then it will show the red shift, means it will be mostly in the red color. But if the same galaxy is coming closer to us, then it will be a blue shift, means it will be a blue color. So this is how we able to determine whether the galaxy is coming closer or getting farther, and on basis of the color and the wavelength and the frequencies, we are able to determine the distance between that galaxy and the Earth. Now it would be really interesting if I give you an example of the Andromeda galaxy, which can be found in the southern hemisphere, the MC12 galaxy. Too much complicated, just an Andromeda galaxy. Now Andromeda galaxy is the only galaxy which is showing the blue shift, so it means that it is coming closer to the Earth. and no reason why, because it's still a mystery that why it is coming closer to us. So the Andromeda is one of the examples for the blue shift, and the red shift, there are plenty of them. You can easily Google it down. So this is what the Gemini telescope is all about. Then the next one is basically in the list is the Event Horizon Telescope. Event Horizon. Now, it has been basically the image. This is basically used for the black holes, because the word of the event here, as we have already discussed the event, and maybe not. We will discuss into the next chapter. When we study about the physics and basic physics regarding dark and dark energy, dark matter, and the black holes. So generally, what happens? The black hole are basically completely invisible, but the only way to detect them is through an event horizons, and that is why the name is Event Horizon Telescope. So it is generally used to detect black holes. Now, the first ever picture of the black hole was captured by this telescope itself. So it is basically the network of 8 telescopes which has been placed in Hawaii. So it is synchronized in such a way, in effect, they form a radio telescope of the size of the Earth itself. The name the black hole captured was kept the Powai. So the first name, they have detected, so they named it as Powai. So this is what they have named the first ever black hole which is detected. So you can Google it down to see the image itself. It's pretty amazing. The next one in the list is the 30-meter telescope. Now the 30-meter telescope is basically a multi-wavelength large telescope near ultraviolet mid-ray observations, and the proposed site is the Mauna Kea in Hawaii. It was pretty much in news last year, because the local peoples of the Hawaii were, they were angry that we are making such telescopes there. That's why. And the second telescope is basically in the Hanle, Ladakh. And the funding we got from the Canada, China, Japan, and India. So this is pretty much about them. And the resolution of this one is actually the 12 times more sharper than that of the Hubble Space Telescope. So it's pretty good. And there are 492 segments creating an array itself. No, it's not an array actually, but 492 segments means the different pieces of the mirrors have been used in this thing. That's why it provides a huge, sharper image than the Hubble Space Telescope. So this is what it is about. The next one on the list is, so wait a second, that was 4th, right? Yeah, so we'll write it here 5th. It is dark energy spectroscopic instrument, which is called the DESI. Okay, that is the dark energy spectroscopic instrument. So actually it is designed by the Lawrence Berkeley National Laboratory to explore the mystery of the dark energy, because the name itself says dark energy, yes. So basically to explore dark energy. We'll discuss about it in next chapters. And so the DESI components are basically designed to automatically point at pre-selected sets of galaxies rather than their light. So what we do, there are certain galaxy, and we automatically select them, gather their light, and then split that light into the narrow bands of colors to precisely map their distance from Earth and gauge that how much universe has expanded as this light traveled to the Earth. Uh, I hope you have understood these things. You can rewind it again. So what it basically is about, that, for example, like these are certain galaxies. So what we're gonna do, we will project toward these galaxies, we will capture their light, we will capture its light, and then we will divide this light into multiple narrow bands. So these are the narrow bands, right? And by dividing a light into the multiple narrow bands, we are able to calculate the distance of these galaxies from Earth, and on basis of that we can able to decide that what speed and how much the universe has expanded, because on the basis of that light itself, so we will decide about the universe expansion. So this is what we do. So this is what the DESI does. So I think I pretty much made it clear here, the role and usage of this thing. And it is basically the Berkeley. So Berkeley is in US. So it's a US project. Apart from that, the next one in the list is MEERKAT. It actually inaugurated in the South Africa, and it will be the biggest radio telescope of its kind in the southern hemisphere. So it is in South Africa, and it is basically the biggest radio telescope. In southern hemisphere. So this is what it is about. And the next one is the Starlink. The 2 days back there was a Starlink launch again. So I'll explain what it basically means. So the full name is Starlink Internet, right? Internet Constellation. So basically that is a project of the SpaceX, most of the people as know. So they have successfully deployed all 60 Starlink satellites till now in the orbit through the Falcon 9 rockets. So basically the Starlink satellite and what it does, so let me explain you this. That's an Earth. So what are they doing? They will place certain satellites all over the Earth, which are basically the 12,000 satellites in the low Earth orbit itself, in the distance of 350 kilometers to 1200 kilometers, here everywhere, basically creating a constellation of satellite through their rocket, that is basically the Falcon 9 rockets, and with an aim to provide the low cost, reliable and uninterrupted space based internet service to the world. So yes, this will provide the internet services to world. This is what it does. Now about 4 billion people do not have access to the reliable internet, as a traditional method to access the internet using the fiber optic network and the wireless networks is not worth it. So that is the reason why the Elon Musk came with an idea that yes, let's create a constellation, and that constellation is well capable of providing internet to everyone. So this whole project is basically called the Starlink. So at present I think there are more than like 60 satellites have already been placed, and the 12,000s are more to go. So this is what it is. But the more problem is this, that this will create a more space debris in the future, and I don't know how would they tackle this problem. So this is what it is. Next is basically the OneWeb. The OneWeb is again a constellation of satellites in the low Earth orbit, but it is not yet launched. It will be launched in 2021. So I will write just a name here. This is called the OneWeb. The same purpose as the provider satellite based broadband services. So this is where we end the series of the space missions. In the next chapter we will study about the basic physics and the astronomy. Thank you guys. Let's see you in the next lecture.